Solve using matrices. X plus 3y minus 3z equals 12. 3x minus y plus 4z equals 0. Negative x plus 2y minus z equals 1. So let's write out the corresponding matrix to this system of equations. We take the coefficients 1, 3, negative 3, the constant 12. Then we take the coefficients for row 2, 3, negative 1, 4, 0, and then the coefficients for row 3, negative 1, 2, negative 1, 1, our vertical line separating the constants from the coefficients. All right, what we want to do is get zeros in this position, and this position. We can do these at the same time. What we would do is take row 2 and subtract from it 3 times row 1. That will give us a 0 here. It's even easier here. We'll simply take row 3 and add row 1 to it. And that will give us a 0 in that position. So we start by recognizing that row 1 remains unchanged. 1, 3, negative 3, 12. Row 2 minus 3 times row 1 puts a 0 there. Row 2 minus 3 times row 1, negative 1 minus 9 is negative 10. 4 minus 3 times negative 3. So that's really 4 plus 9 for 13. 0 minus 3 times row 1 is negative 36. Row 3 plus row 1 gives us 0. 2 plus 3 gives us 5. Negative 1 plus negative 3 is negative 4. And 1 plus 12 is 13. And put our dividing line. The only thing now is to get a 0 in this position. One way of doing that would be to take row 3 and add half of row 2. So row 3 plus half times row 2. That means row 1 remains unchanged. So it's 1, 3, negative 3, 12. Row 2 also remains unchanged. 0, negative 10, 13, and negative 36. Row 3 plus half of row 2. So that's 0 plus half of 0 is 0. 5 plus half of negative 10 is 5 plus negative 5, 0. Negative 4 plus half of 13. So it's negative 4 plus 13 halves. And let's deal with that in a moment. And then it's 13 plus half of negative 36. Well, half of negative 36 is negative 18. 13 plus negative 18 is negative 5. So now we have zeros in the positions that we want. The only thing I'd like to do is simplify this part. This would be negative 8 over 2 plus 13 over 2 gives me negative 5 over 2. I'm sorry, positive 5 over 2. So now what we have is the equation from this row 3 would be 5 halves z equals negative 5. Multiplying both sides by the reciprocal of 5 halves, which is 2/5, gives us a value of z, negative 5 times 2/5 equals negative 2. That's the value for z. Now what we'll do is use that value of z and substitute it into the equivalent equation from row 2 of the matrix. So let's do that next. So the equation from row 2 of the matrix is negative 10y plus 13z equals negative 36, and we just determined that z is negative 2. So negative 10y plus 13 times negative 2 equals negative 36. This is negative 26, so negative 10y minus 26 equals negative 36. Let's add 26 to each side, so negative 10y equals negative 10. That means y is equal to 1 because negative 10 divided by negative 10 is 1. From the first row of that matrix, we know that we have x plus 3y minus 3z equals 12. We now have the value of y is 1 and the value of z is negative 2. So we have x plus 3 times 1 minus 3 times negative 2 equals 12. That's x plus 3 plus 6 equals 12. 3 plus 6 is 9. X plus 9 is 12. And subtracting 9 from 12, we get x equals 3. I've checked this answer already, so we know that the solution is the point x equals 3, y equals 1, and z equals negative 2.